Hello Internet, it's Michael again, doing another live stream code session. Last time I left off, I had set up text file writer, a helper class for streaming data to a text file. And the key feature of the file system's text writing stuff is that it doesn't directly write to the text file. Instead, you provide it the path of where you want the stuff to go. So in this case, like in this example of save entities to text file, I'm saving to this file in the save directory. And then when the file closes, it copies the file data to that location from the temp folder, which makes it a little bit safer to save data. So I've currently got the data folder redirected, so I can actually monitor the way that data is saved to and from each of these folders. So for the sake of this demonstration, I have loaded up the contents of a scene, which this isn't actually what you're looking at. I don't have a renderer system set up for the scene yet. But what it does is it loads up the scene from file. It takes and serializes it back to a temp file in here, and then copies it into the location that I specified. So I can actually open up the YAML file and see the contents that I had serialized. And literally, it's just a copy of what I had loaded up from the content folder in the first place, which was this guy. Literally the same data, though there is the caveat that I didn't reformat this into flow style when serializing. I did it per line. But now that that's all working, I just gotta fix up some nice to haves. The first would be to get the OStream operations going, so that instead of having to cast everything or convert everything into a string before it gets serialized, I just pass it an object that has an OStream overload, or bit shift left operator, and it just converts it automatically. So that would look something like, if I go to make a text file writer, it would be like file, text file writer, writer, and pass it a path like, put it in the user data folder, example.txt. I could just go writer and then bit shift left and then type in whatever data I want. So I could like use I could serialize a matrix directly into the writer, as long as it has an overload for the bit shift left operator to convert to OStream. So that's something that I've never done before, but it's something I am for sure interested in getting done, because that'll make it a lot easier to serialize stuff to a text file in whatever format you need for your game, presuming that you want to use text files. So to do that, I'm actually going to first look at an example of a class that has done it. And it has occurred to me that I have access to one in this project, or linked to this project. I use YAML CPP for YAML serialization for my scenes, and it uses the bit shift left operators to put things into the emitter. So if I was to go to the emitter and take a look at its operators, seems to me like they probably can be a point of reference. Yeah, so we would do in this case they did inline I probably would also do inline. I don't see any reason why I wouldn't. Operator, left shift, and then I would take the left-hand side, so the actual emitter, and in my case it would be a text file writer, and then take on the right side the thing that I want to serialize. So one takeaway here is that I'm going to need probably a good number of overloads in order to be able to catch all the basic values and convert them. And then I will need to overload, I believe, an OStream. So that way, if the class itself supports OStream, then it can output itself, and the developer doesn't have to worry about like rewriting the text file writer. They just make their class support the left shift operator. Microsoft had a guide for that that I'm going to Google. Overloading the left shift operator for your own classes just kind of showed how a class would do that. They would be a friend of an operator, so that way that all their private data is available. And then the operator, they would provide an overload where the operator would take the class itself, convert it into an OStream object, and in this case, like date, month, day, year, those things already can be left shifted into an OStream, and then they just return the OStream that already has those shifted into it. And for another example, I want to take a look at stdc out again, because that's the one that everybody uses. And if I go to basic OStream, I can actually see all the overloads that are used for it. And you see that there's a lot in common here between the OStream operators for stdc out and what's being used for YAML. We got short, unsigned short, int, unsigned it. So I think I want to implement all of the common ones here, and then I want to overload std basic OStream. Not sure if I care about these others. We'll come back to that if it winds up being important. But the std basic OStream is the one that allows us to be compatible with classes that have done the work to make their stuff able to be shifted out to places like cout. So yeah, let's get that going. So for starters, I probably want to do inline. Inline simply meaning that when you go to invoke the code, it doesn't link, or it doesn't jump to an external function. The compiler just takes this code and places it directly in the location that you invoke it, which is, you know, a small optimization that's worth it for something as simple as shifting out. These are non-templated, and they are members of the class, I think, right? Emitter, yeah, and if I go to the emitter declaration, oh, that is the declaration. Okay, good. So this is all within the class body. Cool. All right. So I suppose I could literally just copy and paste a lot of these. I'm gonna do it a little bit more tactfully though, and think about each addition that I make. So going back to file.h, going to the text file writer, I'm going to, right underneath the write function, I will start adding these operators. So inline operator, and I do this so very little that I have to reference every piece of it. So they got by reference the class, and then the operator symbol, and then by reference again on the left side. So it would be, actually, you know what? I don't think I need to return anything, do I? I suppose I should just return a reference to myself, to the self. Does write return a emitter? I guess it does. Does basic OStream returns a basic OStream reference. The idea there is that when you work with an OStream object, you could pass itself into another. And I don't see any reason why you would do the same for the text file writer. Like, why would you create a text file writer and then create a second one and then pass the one into the other? I suppose you could. I suppose there's not necessarily anything wrong with that. But I don't really see the point. So I'm going to go ahead and do a void return value. And hopefully that doesn't break anything about this process that I'm just not thinking of. Now the left-hand side has got to be text file writer by reference. And I guess I'll just call it writer. And then the right-hand side has got to be the thing that I'm going to convert to. So going through the list, we got short, unsigned short, whatever. I'll just start off basic and say int, call it value. And then we need to define it. What's this complaint about in IntelliSense? Too many parameters for this operator function. Is that the case? Is it? I'm quite sure it's 2. Right? Too many parameters for this operator function. I must be overlooking something. Inline emitter reference operator. Except for its text file writer and text file writer. Oh, except for I spelled it wrong. Yeah, I for sure don't get it. Maybe it has to do with the fact that I'm doing it inside a class. Maybe I misunderstood the situation and this is not part of... It's not. It's part of the YAML namespace. So actually, yeah, this needs to be global. And do I need to make it a friend of... Yeah, because there's the end of the declaration. Do I need to make it a friend? For private data? I guess not, because I would just call the public write function. So yeah, I would need a, okay. So misunderstood the operator overload. Let's go back to file.h, cut that out, and this actually needs to go down below. Got an operator, and still too many parameters for this. It can't possibly be right? Maybe if I finish it, IntelliSense will change its mind. And then we'll call write for just for the sake of I need but I'm not able to invoke writer. What's going on? Why can't I use text file? Oh, I'm a fool. I need to do file, text file writer. Is that really the not enough? Geez, I didn't think I'd be running into problems this early. Maybe it's the I guess it's only expecting one. Let me remove inline. This is crazy. Why is this so hard? Does the right have to be const? That'd be really weird. Let's review how YAML did it. So in YAML, a little weird how there's two private declarations here, but whatever. Underneath the emitter, they've got the constructors, output, state checking, the actual setters. These are all the versions of write that you can invoke from the bit shift left operators. Okay, so there's no mention of the left shift operators until you get to the state outside of it. And at that point they got emitter reference as the return value. The left hand side is an emitter reference, the right hand side is a const string, or a just passing the bool by value. You would think that this would just be enough. That you could just take a class Man, only 20 minutes in and just being thrown a curveball. So, did a copy and paste, and then we're using file, text file, writer, and then it's identical in every other way. I don't see why this should be such a problem. I'm going to proceed with the assumption that this is correct, and IntelliSense is just being a jerk, because I can't understand why it wouldn't just work. So whenever you invoke the operator bit shift with a bool, then it should output test. So I'm going to leave that as is, pretend it's not giving me warnings, and see if maybe it works fine when I try to compile it. Doesn't it? I'm going to try putting it in as a member. You know what? I'm going to go ahead and just say fuck it and see if it works. Writer will close and save to this location as soon as it leaves scope, but I'm going to explicitly call writer.close here. And see if it does anything, if it fails to compile. And if it does fail to compile, then I'll know I need to keep looking for the answer. Yeah, it looks like the build for enterprise failed. So let's try Control X. Yeah, I know. And to be sure the error is going to be the same, probably no operator. Yeah, skipping function body. So let's put this into a public operator. And the left-hand side is implied. We'll use the right-hand side only. And we'll say right. Oh wait, I would just say right and then return this. Right? Dereference this. I have a feeling there's something wrong with how I did that, but I'm leaving it for the moment. We'll see whether it shifts out correctly. I should probably learn what that operator is actually called. I call it the bit shift because that's what it is when you're using bitwise math, but when it's used as a output stream operator, I don't think it is technically called a bit shift operator. I'll have to look up the name so that I can be technically correct when I'm talking about this. Okay, that compiled. I've got a warning here, cannot create a file when that file already exists. Not sure what that could be referring to. Maybe there's something else that I need to worry about. Saving to, yeah, user example.txt, this is it. And it outputted test. So that tells me that the operator overload did work this time. So I guess that's how I'm supposed to do it. I have to do it as a member function, though I'm not clear at all why I can't do it as a free function. You'd think I could, but I can't for some reason. I don't think I have any reason to put the writer on the right-hand side of a bit shift operation, so I'm going to go back into, H. Head down to text file writer, and instead of doing a return value of a file text writer reference, I'm going to return void, and then not return the value, just say write test. Actually, I'm just going to go ahead and say write v. What I just did here is a ternary operator. Basically, it's a quick if statement that says if v is true, do the left side. If it's false, do the right side. So the left-hand side is going to say true, and the right side's going to say false. So it just prints out true or false depending on the bool value. Yeah. So in this case, I've got that. Press F5, and then I'm going to need to take a look at that error that popped up in the console about not being able to write to a file that already exists, because I shouldn't be seeing that warning here. In the last stream, what I had done is I had implemented a method that detects when the file already exists and deletes it to replace it. And it shouldn't be producing a warning. Yes, I'm still getting error 183. Is the file still outputting correctly? It appears to be working correctly because it still says true. Well, it says true now. Last time it said test, but true means that it did indeed output correctly. I am getting multiple temp files though. Oh, that's interesting. So the the error message that I'm seeing must be coming from my serialization to YAML. Let's take a closer look at that. One of the only things that I've done since the end of the last stream was previously when I was serializing the YAML file, I would just print the contents of it to the console, and I changed it to use the save text file API. So I guess this is causing a problem because it's not taken care of. Oh, okay. Yeah. So during the last stream, I had implemented on the text file readers class during a text file reader close. I had implemented logic to identify first whether the file already existed, and if it did, to delete it in advance of moving the file from the temp location to it. So I haven't actually done that in the save text file method, which is basically instead of having a stream object where you just push out data one piece at a time, you take a string and then that goes straight to a file. So I need to do that. So first we've opened the temp file, we've saved everything to the temp file, and then down here is where we use the atomic move to the destination. So that way we take everything out of the temp temp folder and put it into where it's going to go, so that we're not accidentally corrupting a file if we lose power or something. So I just copied and pasted in the code for deleting the file if it exists. I need to update a few things. So this is the handle for the test. Basically the test involves just using fopens and saying if the file opens successfully, and if it doesn't, then we would proceed as normal. But if it does, then we would delete it if it does open. So instead of destination path, I need to do new path, or is it just called path? What function am I in? Right, I think it's just path because path is the parameter that I have provided. However, path needs to be converted to a from a virtual path to a platform path. Because right now it's using the virtual file system. You provide C/whatever to get to the content folder, but that could be anywhere on the computer. I would use vpath to native path to convert that first. That'll give me the native path of path, and then convert it to a C string so it'll work with fopens. We're just reading to confirm that it'll open in the first place. So if the error code is not equal to e_no_ent, which means the file doesn't exist, then we would go to delete file and handle it there. Give me just 1 second. Sorry, I had to dip out for a second for something. Anyway, going back to the change, if this is the case where the file exists in some fashion, it does include the possibility that the file exists but can't be edited for some weird reason. But I am going to simply attempt to do the delete call anyway, and then if there's a problem, I will handle that here if it returns 0. So new path so delete file needs to receive new path as wide, which means I actually have to move these higher. New path is wide. Basically, delete file and the other Win32 API stuff, they take wide strings instead of regular narrow 8-bit byte strings. So I have to cast the or convert the string into a wide string first, and that's done using a helper function I wrote up here. Cool. So we got EP error, the error message needs to be updated with the correct function name. So in this case, it's file, save text file, and we'll say file already existing cannot be deleted. And we invoke getLastError. I probably am going to I'm probably going to consolidate this into just a helper function at some point. Because right now, I just kind of whipped this together using code that I had written for another library. Right now, that just prints straight to the console using the WC out, so the wide character standard out. I want to probably get that to work better with my logging system to actually output using the same logging that I use for everything else. But for now, this is fine. Just for getting everything running. And I hit return. Is that what I want? I believe so. Hitting return will curb us from trying to move the file, but it will also leave the file that we wanted to write into the temp location. So if you're a developer and you do need access to that data, you can just pull it out of the temp folder, which if you're debugging and you're using the redirection, it's all nice and handy in one place rather than scattered across your computer. All right, so that should be that for the problem we had with serializing the text file. I went ahead and deleted the temp file. I'm going to press F5. If this is working correctly, we can tell already that it's not. What's the error? What did I miss? File return a value. Does it need to return a value? What? Oh, it needs an error code. So I guess it would need error code. Already exists, I guess. But it's actually not just that it already exists. It's also that it won't delete. So I guess that would be permission failure. Probably should do a little bit more homework and actually specify what getLastError is telling us, but I'm not interested in being very robust right now. I just want to get it working. All right, so if this is working correctly, then I should see in the temp folder is created, nothing in the temp folder. We go to the user folder, or sorry, the save folder. I think it's. I was just testing to make sure that all the folders worked. There's no reason why I keep putting them in random folders. Everything has come out correctly, and we don't get a warning saying that we can't overwrite the file. So it is apparently successfully overwriting the file, and one way we can check that, let me open up the file itself again. Right now it's got on serialized object 1 an x value of 15. If I was to leave that there, go to my content folder and change the value from 15 to 5. Now if overwriting the file works correctly, now that I've run the program, if I was to go back to the data folder, data, save, and open the file now, it should say 5. It does. So overwriting is now working correctly, and we're not going to see that error message anymore. And the temp file is going to be nice and clean, probably. Another advantage of having the temp file just available for me to see directly in the project folder with all these others is that I can tell right away whether something failed to move, even if I didn't catch it with the console message. So cool, that seems to be working. Let's go back to the main folder. I should probably open that main window again. I typically leave Visual Studio Code open while I'm working, because I like to edit the data files in here and edit the code in Visual Studio. And I know that literally both can handle both, but I don't know, just the way that I am. I'm getting a warning on fclose though, in both locations. Because I am not initializing test handle before I invoke fopens. Do I have to? Is it really going to make me do a check that it's not null? I guess so. If I mean, it's one of those things that's technically correct, but I don't like it. If test handle, then I call fclose on it. Hopefully that'll. Let's see whether that causes it to stop complaining. Actually, strangely, it doesn't. So maybe I'm misreading the complaint. Let's go back to the. Oh, that's interesting. It just disappeared for no reason. This one didn't, though. Going to. If stream is null, the invalid parameter handler is invoked. Yeah, so I guess what it is complaining about is that it's technically possible for it to be null, and then we invoke this code. Because there are conditions in here, if the file doesn't exist, oh sorry, if the file doesn't exist, there's also other situations where, oh, okay, this is actually a good warning. I think what's going on is that besides the possibility that the file has successfully opened or doesn't exist, there's also the possibility that we're attempting to open the file does exist, and it won't open. In which case, it doesn't equal doesn't exist, and we would invoke fclose on a null test handle. So actually, that's a good point. I should be invoking this only if the error code equals 0, I think. Right, I think that's how it works. Always having to Google search the thing I'm working on right now. I think the error code returns if successful. Wait. If successful, it returns 0. Okay. So if it did successfully open, then we would close. I'll add that little clause in there. I do still want to keep this all within the block of anything besides the file doesn't exist. So for simplicity, I'll just do that. Let's go back down to this guy. Place it. Hit F5, and those little warnings will go away. Ideally. Boop. Is it actually going to make me? Is it actually going to make me test handle? Okay, it's not. It just took IntelliSense a little while to realize that this was okay. All right, perfect. Cool. So we know that the. Okay, cool. Now let's get back to the bit shift operators before we got sidetracked by all the little warnings that we saw on the sides. So this works, this method. If I go back to file.cpp now, didn't mean to pin it, but here we are, and go back to our file.h, sorry. We go back to the inline void operator. I now just kind of need to do this for all the operands that I might use. In all cases, the file writer is going to be on the left operand, so I can do this as a member function with one parameter. But the troublesome part is I need to do this for enough operands to cover all my bases. So let's go back to cppreference.com and go to cout, std cout, and take a look at its, well, those streams. Take a look at all of its operator overloads. So they've got short, unsigned short, int, unsigned int, long, unsigned long, 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 unsigned long, long. That's a mouthful. Float, double, long double, bool, which I've already got. Do I care about void pointer? I mean, I guess I might one day. It's just an address. And then volatile void. Actually, not volatile void. I'm programming in C++ 17, so I don't care about C++ 23 standards. Null pointer type. And that'll do for now. So let's do 13 copies of this. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then we'll start doing all the types. So we've got short, unsigned short. Int, unsigned int. Long, unsigned long. I could probably do a lot of these from my head, but that's an easy way to forget a specific case. When we're doing long and, or long, long and unsigned long, long, long. Float double, long double. Bool is the one we already have. Constant void pointer and volatile void pointer. Or constant volatile void. Oh wait, I'm not doing volatile void. I'm doing null pointer type. Okay. And what this is referring to is that technically speaking, when you are working with pointers, C++ has a value null pointer, which is different than just using null or zero like you would in C. It is used because it is type safe, meaning that it's not going to be mistaken for an integer by the compiler, which in C it literally always is, because you're just using null, which is a macro for zero, which zero is a null address, but that's, yeah, you want to use null pointer in general instead of zero or null in all caps when you're working in C++, because it just makes the standard library like you more. And then the rest I will deal with later. I don't think I care about any of the stream buffer, iOS base, and things like that, because I'm only interested in serializing data with this object. So straight up data and objects that have been modified to serialize themselves as an OStream. So I guess I can add that operator now, even if it doesn't work correctly. It would be std basic OStream. And do I need to provide CAR-T and traits? Like, does this need to be templated? I'm unsure about that. What does YAML do when YAML does it? We're back in the YAML header now. Taking a look at the various overloads. Emitter, manip, indent, precision. I'm not sure what those are. Null, binary, comment tag, alias, string, template, string stream. Okay, so these are not what I'm looking for. I guess it's not in this file. That's interesting. Taking a look back at the example that we have from the Microsoft docs about overloading the OStream operator for a class that you want to serialize. And it doesn't mention the template when you're looking at the return type. It just says OStream OS without specifying. So, oh, what am I saying? Basic iOS is the type of OStream. Or it's the generic of OStream. So OStream is actually a template of this. So if we go to input output, I guess we would just go basic OStream. It is, yeah, okay. I was confusing myself for a second. So I actually do want these types when I am overloading the operator, or these types for std basic OStream. I'm not sure if I care about the others. I'm pretty sure I don't. So I'll just, if I encounter a problem at some point in the future using left bit shift operator to output stuff to a file, I'll deal with it then. But coming back to file.h, duplicated the null pointer one, and I will be using this. Does that work? std cart. No, that's not right. Cart is presumably just a generic character type. So it can either be car or w cart. Can I do both, or do I have to do both separately? Or can I just say car type? No, I can't. So I guess I'm gonna have to overload this for car and wcar. In traits, would be std cart. So actually I can leave that blank because it'll default to the type I need. So it defaults to calling std cart traits on whatever cart is. So I can do wcar here. Or can I do wcar? Do I have to do std wcar? I forget. Oops. Fundamental types, that's the page I was looking for. Oh, it's wcar-t, that's right. I am just rusty as hell on these things. All right, cool. So that's actually all of the operator overloads I want. Now I have to implement them. And the only one that is correct right now is this guy, because it's as simple as saying print true and false if false. But to these others, I actually had to do the conversion. Can I literally just say V on a short? No, I can't. So I do need to do some conversion. And I guess I'll have to use C-style stuff to convert. Or I can use a host stream conversion, which I'm already within an operator that I don't want to make another. I don't want to construct another O stream. So let me open up hot constants. Hot constants is a reload library that I use in this engine, and what it does is allows you to use a macro to replace a constant declaration with an atomic type that is monitored and reloaded by a separate thread at runtime. So I happen to know that I went through all the trouble of writing code that converts all of those types when I did hot constants the first time. So I guess that would be under reload hot const. This is it. Get HC stack of type. Oh, and I just okay, SD pair eval arithmetic expression. Let's go to that. I'm just gonna follow up the chain for conversion, or maybe I can just scroll until I find it. Cast literal type literal int. Okay, so here's the casting stuff. Except for it's actually literally a cast, so that's not what I need. Really? Oh, C++ parsers are actually fairly complicated, and strictly speaking, I literally have written a full recursive descent parser here, so it's been well over a year since I last looked at it in detail, so I'm not actually following my way around very well. Evaluating expressions, expression evaluation stuff, what that was about. I guess this is the wrong file. Let's take a look at hot constants, source, literal conversions. That sounds right. Okay, so this is just about literal identification. So checking out things like whether there's an F following the number to indicate that it's a float. Identify operator. Okay, Okay, conversion code. Here we go. Convert literal to int. So I got a string that contains an integer, and I know what base the integer is going to be converted into. S2I. Oh, I'm being an idiot. Per usual. S2I. So at no point am I actually writing to file in constants. So I'm actually looking at the wrong thing. But remembering now that I'm using S2I to do the conversion, I think there's an alternate one. Is there an I2S serial plus? STD2 string. Okay, that might be. Oh, perfect. That seems like all I need. So I literally just pass for all of these basic types. I can just do std. I can just call toString within the string header. So std2 string. And I've got string. I use actual strings all the time, so it's already in my precompiled header. I just do std2 string and convert those. I don't think I care about the rest. All right, let's get back to the serializer, the writer. Oh, I need to be in the header file.h. Okay, so I can use std2 string for almost all of these. With short, I can just overload it to use int because that's a widening conversion. I'm not going to be losing anything. Technically, this is an unsigned int, but it's missing the int. It's implicit. So yeah, I think that actually covers all my bases, except for void pointer, but that could technically be an unsigned long. I'm a little surprised that this doesn't feature the fixed width types as overloads, but I mean, maybe that's implied. Because technically, like, int's width is not defined here, it's defined per platform. So some compilers may use 16 bits, and others might use 8, even though almost all of them use 16. So, yeah, I guess this would default to using long. All right, without further ado, let's go ahead and start writing these. That would be std2 string b, and it's going to be literally as simple as that for most of these. Actually, let me just copy the whole line and make it easier to paste. Double, long double, and pasta. All right. Yeah, and so it automatically overloads to using the int type for the parameter. Even though it's a short, but it's widening, so there's no data loss. An unsigned int should just be the unsigned. Actually, it does fully complete as unsigned int here, even though it says unsigned in the docs. Well, yeah. I'm just quickly double checking each of these to make sure that they're calling the right. Overload. Oh, I'm using the wrong. I'm inspecting the wrong thing. Long double, yeah, long double, float, long, unsigned long, unsigned int. Okay. So that leaves the constant void pointer. This is always going to be the width of pointer type. I wonder, yeah, so no overload will take that. I wonder if I convert it to let me go back to the fundamental types definitions again, because what I'm wondering is if I can force it to use long int, or sorry, unsigned long int, because the unsigned long int is here, unsigned long, and these are data models for common processors. So very commonly, if you use long int, it will be 64-bit. But that's not a guarantee. What I really want to do is I want to cast it to uint64t. I wonder if I do that, if I do uint64t, if that'll just work, because the compiler can infer the type that it needs. Yeah, it uses unsigned long here automatically. Now, is that valid? Should I be using a different type to ensure that it's actually matching a pointer? Because, like, you know, who knows? Maybe if in like 30 years there's a if they invent 128-bit processors, for example, then this would be. But I mean, that's 30 years from now. I think this is probably good enough for our purposes. So I'll leave it. Oh, you know what am I saying? I just realized that I'm shooting myself in the foot for no reason. In order to specifically to avoid problems like this, I am working in 64-bit only. I don't build enterprise for 32-bit. It does not support 32-bit computers, and I'm not planning to add support for 32-bit computers, because really, I mean, you know, it's 2021. Everybody has 64-bit computers. So actually, yeah, I think it's safe to leave it like that. I'll just cast it to a uint64t, and then presumably that will cover our needs. And then for operator for null pointer type v, if it's a null pointer type, isn't the value always 0? I'm pretty sure it is. Null pointer type is basically just a way to ensure that the null pointer literal is not confused with an integer. It doesn't actually. It's not a type that can be anything else, right? I think it literally always equals 0. I could also just say output null as the value if it's a null pointer. But if I did that, then whoever has to read the file back into their software has to consider that it isn't written as the word null instead of. I wonder what the std cout does, because I may want to mimic that. I'm going to come back to this one. And then I'm gonna blank out the OStream stuff for the moment. I might as well blank out this one as well. And I'm just gonna run some tests to make sure that the operator is working the way I want it to with these basic types. And then I will test out for a null pointer type what it should probably be. I'll try and match what people would expect for another OStream sync. And then I'll worry about handling this for types that wants to make themselves serializable using the OStream operator. All right, cool. So I think we're on track. Let's go back to this. I'm going to start inputting some literals. So first I'm going to use the number 42 to test out integer output. Actually, you know what? I don't have to do much else. Oh, I need to do strings. Let me get back to stdcout and refer to its I need to go to its parent OStream, basic OStream, which its shift operators will accept those values. I guess strings would be covered by one of these, so I'll come back to that. I may want to just implement std string on the right and just have it explicitly invoke, but for the moment we'll skip that and just do writer.write and invoke the string directly. And I'll just do a new line for each of these. And I want to do a test for every type. So I've got short int, long, unsigned short, unsigned int, unsigned long, float, double, long, double, bool, void pointer. Yeah, bool and void pointer, so two more. All right, and then I will proceed to give each of these. I forget the literal for shorts. There's when you're doing literals, you can actually put for all the integer types, you can put a little letter next to it to tell you to specify a specific width or whatever. Here we go, integer literals. I could just cast it, but I'm curious now what the suffix is. Suffix is decimal, hex, binary, integer, unsigned, u, long, site suffix. Oh, okay, so I guess there's not actually a short suffix or prefix. There's just the unsigned and long and long. All right, so I'll just do explicit casting. Short. And then that's already an integer. Long, make this a long. I know this is pretty tedious, but it's the sort of stuff that ensures that you're not screwing things up. And I'm just going to replace these next four with what did I screw up? Yeah. Yeah. And then these will be unsigned. And floats. So .of, .o, .ol, or not capital L, but lowercase l. Don't really remember. Either L or capital L will do a long, or a long double. Okay, and then what were the last two? Bool. We actually already tested bool, and then void pointer. And then a void pointer would just be an address of anything, really. So I'll do the address of this vertex, or this vertex array handle that happens to be in the same scope. The address of VAH. And then it closes, and that's that. The close is technically unnecessary because it's scoped. Okay, let's press F5. Let's see what prints to file. Under new example text. That would be user folder. Any second now. Now, thankfully, this is the engine will be the thing that you don't have to compile very often when you're making a game, but I should probably do something about the lengthy compile times I'm seeing. So there we go, updated at 6:37. Okay, good. Okay, it's outputting correctly. So each of the types that we provided is outputting correctly, and even this void pointer address, which is the address of the vertex array handle that I happen to be using to draw the Madeline cube. Cool. Okay, so we've got a lot going on. We don't have O strings. We don't have null pointers. We don't have strings. I may just do strings directly. But if it's covered by one of these down here at the bottom, and I'm not clear at all, it might be basic stream buffer with CAR-T. I'm not clear at all. If it's covered by one of these, then maybe to be more fundamentally complete, I should come in and do these additional types as well. So we got basic iOS. iOS base. What does std string come in? As a basic string, it doesn't have the parent. Doesn't look like. So basic string is templated, but it's not, apparently it's not got apparently it's not a child of one of these types. So my best guess is that it converts into something, probably a stream buffer. Input and output to a character sequence. This is one of those things that I think if I had gone to fancy lad school, I probably would have been taught this in my first month or so, but I think I am overlooking something. I thinking it must be this because it's the only other type that it takes that accepts a character template parameter. So this must be, there must be a constructor for strings. No? It also takes a basic stream buffer as a constructor. So I guess it's neither of those. So it's not stream buffer, not basic iOS. Is it OStream? Can we construct an OStream from we construct it from a basic stream buff again? Is everything point back to a basic stream buff? Maybe the answer is in the STD string class. Maybe it has a conversion to an O, or a converter operator into a O string. Ah, okay, perfect. All right. So by implementing OStream, we are also already supporting SD string because it has a operator overload to convert into a OStream. Okay, that makes sense. I think. Yes. Because this is a member. Input output, yeah, that's a member function, so its parameter is always the right side. Oh, but it's got two parameters. Whatever. But it sounds to me like if I was to implement OStream, the OStream type, then we'd be good. So I'm going to take a break. After we come back, we'll be diving into those last couple of types for serialization. Alrighty, I'm back. Just had to top off my pint glass. Alright, where were we? Right, so we had just implemented all of these fundamental types and the void pointer type. Probably the next easiest one to tackle is the null pointer type. I was a little confused on what to do with that one because I've never needed to serialize the value of a null pointer type. And technically, I mean, I'm not really clear as to why that's even an operand, why they even support this on the basic OStream. Because if you're in a situation where you want to serialize a null pointer, it would generally be in the context that you're serializing a variable to a pointer, right? And you just happen to be setting it as null pointer. I'm on the fence as to whether this one's actually useful, but in order to know, what I'm going to do is I'm going to just do a quick std cout null pointer. And I just want to see what that looks like on the console. And actually, for the heck of it, I'm pretty sure it's the same, but I'm going to call eptrace my trace logging function and try and log null pointer and see what that does. See what they say. See how I should be serializing those. Okay, what? Apparently this was enough to cause an assertion to be thrown. Going back up the stack trace. Okay, it's apparently not the cout that's the problem, it's the eptrace. I guess the SPD log doesn't handle this very well. So, yeah, let's take that out and see how std cout does it. It must be that null pointer was a low enough use case that they didn't bother to add serialization for the logger either. Yeah, so it literally prints out the word null pointer, which is fascinating to me. I don't know why that's valuable. There must be some reason why they put it as an overload for OStream. Maybe it's just even if there's not a practical situation where you'd use it, maybe it's just like a matter of being complete. Or out of curiosity, let me try making a void pointer test var and set it equal to null pointer. And then I can try and serialize test var, and I wonder if it comes out as null pointer. Yeah, it comes out as 00000, because it's not null pointer type at that point, it's void pointer type. And if I was to, oops, I need to stop that. Test var. Yeah, I know you're gonna crash. I know, stop it. I just was trigger happy. Test var. If I go to use eptrace on test var, I'm willing to bet that it'll serialize fine as well. Yeah, it just comes out, and it actually handles it as hexadecimal. It prints out 0x0. So yeah, that's apparently the correct thing to do with a null pointer type is to print the term null pointer. So I guess that's easier to do than I thought it would be. So we just do null pointer for its out. Yeah. And then we'll be good. Let me write in the test. Pointer. Right. Okay, there we go. And then let's implement the operator in file.h. There we go. And we're going to be writing, literally don't even care what the value v is. We just literally write null pointer. And then just like that, we've got an operator that works for null pointer type. Right? Oh, I've used the word. I missed a letter. Stop compiling, I was wrong. Cancel. Alright, let's do this again. Oh, right, I was looking into the console to see what the output would be, but I forgot that we're writing to a file in this case, so I need to go to the data folder, and I'm putting this in save for now. Oh no, I'm not putting this in the user folder for now. And it says null pointer, which is exactly what we want. So that's that. Out of curiosity, I'm curious to know whether this works correctly. IntelliSense seems to be complaining about bit shifting in again. Maybe this is why you have to return a reference to yourself when you do a override of this operator. Let me do that. I'm going to go into file.h again. And what I'm changing is I'm replacing all of these inline voids with hang on a second. Oops, I screwed something up. Here we go. I'm replacing all the inline voids with inline references to text file writer. Occurrences replaced. All right, there we go. And then I actually have to do one more thing, and that is put in the return this. Yeah, so I have to do return this after all of these. Specifically, I have to return a dereference of this because I'm returning a reference, not a pointer. And this returns a pointer. Does that cause this to start working? It does! Okay, cool. That's better. So now I can just do 335, 167, 4409, or whatever, however the song goes. 867 5309, I think is what it was. Cool. In a second, the date modified here should be updating, and I'll know that I can open it. Good. And good. You can see all the numbers that I shifted in after the first one were shifted in verbatim. Yeah, so that worked great. All right. So that leaves us with the one big one, and that is OStream, because that'll allow us to do strings and string literals. But it'll also allow us to serialize any object which has an OStream operator overload. So anything that's designed to work with printing directly to cout will work with outputting to the text file, in theory. Because there's still those other types that I'm not bothering with right now. If we go basic OStream, yeah, there's still these types that I don't really care about. Basic iOS, STD iOS base, and basic stream buff. So let's do this one. We have char T, which it represents either wide char or narrow char. I'll do narrow char. I'm wondering right now, though, whether that's a good idea. Because as it is, the file format that comes out is UTF-8, I believe, because everything I'm outputting is a narrow string. Would it make sense for me to include the wide char outstream? I'm not even sure what would happen. Let me go to the user folder again. Yeah, because it's the formatting that comes out by default is UTF-8, because that's the output type. That's what I'm shifting in. It's just the narrow, and UTF-8 is the default for that for me. Yeah, I guess let's implement both and see what the wide character one does. Let's go back to file.h, uncomment these prototypes. And then for the narrow char, we will write, oh, I am unclear how to best do this. v.flush, right? OStreams have always been kind of a black box to me. It's just like a thing that I know you override the operator to use, or that you just bit shift in and then it accepts it, but I've never really thought about how do you get data out of it. So let's take a look at its members. You got put, you got write, you got two cars, converts, that's C, this is C also, it's not members. I need to go up one. Flush looks promising. Right, it's uncommitted. Changes to the underlying output sequence. No, that's not what I need. How do I just get the text out of a OStream? After gonna Google it. That's the answer in most cases. That's putting it a little bit pithier than I would have converted no string to an STD string. If you have a string stream or no string string object of reference, just use ostring stream dot str method. But you know that you apparently have an ostream, not a string string, or if the ostream is actually no string stream or a string stream, Candyman. OString RD buff to get a stream buff, then use this post to extract a string. Okay, so RD buff, what does that do? I guess that's only available for string streams specifically. I guess I can just copy it and try it and see what happens. So we're creating an OString stream instead of an OStream. In this case, our OStream is called v, so v.rdbuff, which I don't really understand what that does. It gets a string buffer out of it, and then I can return ss.string. Oh, but I'm not returning. I don't return in this case. I just take and write using the write function. Does that work? Is that all I need? A string stream taking the stream buffer and shifting it in to OString stream. So it kind of sounds like that handles it. It just the operator takes what the contents of the buffer of the OStream object, shifts it into the string stream, and that has a method .string that will let me get the stuff as a string. And then I can write it, and I guess that's it. I'll put the wide version of this on hold for a second. Let's see whether this works. I'll do a quick test with bit shifting. This is a string, and that appears to work. I'm not getting any squiggly red lines of death. Let me press F5. We'll go and wait for the file to update, and we'll confirm that it's writing this is a string to example.txt. Why is the compilation taking so long? I'm not clear on why changing the file header is such a big deal. It's not like we're... I suppose it's an inline function that might be used in any of the translation units, but it doesn't feel like it has that big of a reach for me. Alright, so that did not work, decidedly. It worked in the sense that it wrote something, but the contents of the string are not actual letters. They are, in fact, bullshit. So, where did we go wrong? Let's go to, if you have a string stream or an OString stream, use the OString stream method to extract a string. But you know that, and you apparently have an OStream object, not a string stream or an OString stream. If your OStream reference is actually an OString stream or a string stream, use ostring.rdbuff to get a stream buff. Then use this post to extract a string. So, I guess maybe the problem is that I don't know that it is converting to a string stream. If I go back to the basic OStream operator, I know that the only conversion that exists from std string out of this pool is to basic ostring. Going into the bit shift left and bit shift right operators, it takes basic string. Oh, did I just misread this? Hang on a moment. std basic string reference. So the reference to the basic ostream reference. The bit shift left, the left parameter, the left hand side is the ostream. The right hand side is the basic string. Oh. Okay. What? Is this a member function? Yeah, it appears to be. There's no non-member function that includes these operators. I appreciate the dev's humor here. Hello world. To mix it up a little, I guess. So the operator for basic string doesn't actually convert the string into an ostream. But providing the operator to receive an ostring apparently is enough to allow me to submit a string to it. So this must be converting to, and so there must be a constructor for ostream. Here's basic ostream. There it is, basic ostream. Constructor. So it can be constructed from a basic stream buff. And does a basic stream buff have a constructor from a string? That would be, I don't think that implicit conversions go that far. The only thing I can think of would be that there's some other version of, or some other overload that I haven't implemented that would better suit a string, and that because I don't have it, it's using a bad one. Let me real quick try wrapping the string literal with an std string. Aha! So the operator doesn't actually work with std string. It is using the literal for a separate purpose. Okay, and I think we're getting somewhere. How can we use this though? So it was trying to interpret the string that I plugged in as a piece of data that wasn't actually a string. So it was converting to an O stream, but strings are not supposed to do that, I guess. They're supposed to convert to a different type that then, okay, so I need to implement some of these other types. I think. We'll see. All right. Coming back to the other operators that we have yet to implement. We haven't done std basic stream buff. Let me go ahead and, you know, for all the fuss that I'm providing by doing OStream, I could just implement the overload for std string directly. But I still do need this. If not for strings, then for other classes that have an overload. Like, I think this is how pretty print works. Pretty print. Pretty print is a library that makes it so you can just like shift out arrays. So like if you have like a vector of objects, as long as the objects themselves can print, then you can directly print the vector. And it prints nicely with little angled brackets and everything. That's why it's called pretty print. And I think it does that here. When it does it converts to a basic O stream with tcar, and so it is templated. They use the template. Oh, is that important? I was just assuming that we had to substitute our own. But if we actually make the operator overload a templated type that accepts T and tcar and tcar traits, I don't know what delimiters is for. It's apparently for something else. Actually, then I might be able to just do this as a template and not have to deal with wide string or narrow string. And for all I know, there's another type in there that I need that I'm not using. There we go here. Okay. And then I need to do template. Is that right? Type name, I'd say type name. The idea is that when this operator is invoked, the compiler can infer which types needs to be substituted here and here. Actually, I'm curious whether that's enough to fix the problem. No, it's not. It's still giving me that warning when I do std string. This is a string, still works, but I'm expecting it'll output the same random number that doesn't mean anything to me. Okay, file was updated. Yeah, it still contains the number instead of the actual text. So I should know that it's working when this goes away. Let's go back to file.h. I'm going to assume that this is the wrong way to print. And let's do the other one now. Let's do stream buffer. This also has CAR-T traits. So what we can do is we can do yeah, is that right? I guess we'll see. And we do the full Monty here. We'll do template, type name, CAR-T, type name traits. Oh, that's CAR-T, not CAR-T-CT. We make this inline. And taking a stream buff, a pointer to a stream buffer. Explicit type is missing. Oh, I need to return text file writer ampersand. And then that should be enough. Eventually I want to put all the leading braces at the bottom, but we'll deal with that later. Now I've got a basic stream buffer. So SB has got a lot of members. Keybase, gpointer, uflow, position. Is there just one that says string? No. Let's take a look at what basic stream buffer has got up its bag of tricks. So it contains a thing called a sink for output and a source for input. It's not actually clear to me whether I want the source or the sink. I would assume the sink, but for every question I have, there's an answer on Stack Overflow, so I'm just going to Google this one as well. So on basic stream buff to string, copy a stream buff's contents to a string. So we can do a string stream and then just shift in. That actually seems simple as dirt. So let's do that. That's literally what we did up there with the other Stack Overflow answer. Let's give that a shot. Go back to dev state. And we still got a problem. Still not doing it. Okay, yeah, that's not it. let's go back to file.h. I'm going to uncomment this because it kind of seems like this is good for something, if not for what I actually need. And we'll just go ahead and implement the others until I got one that works. Oh boy, oh boy. All right. Oh, is this the wrong tab? It is the wrong tab. All right, here we go. So now we've done basic OStream, we've done basic stream buff. Let's implement STD iOS base. That's a what? What's the description for 11? Calls func this. These overloads are used to implement IO manipulators such as std and l. I don't think I need that because so what this is actually is not taking as its parameter a data point per se. It is taking a function pointer that accepts a reference to an std iOS base and returns a reference to an iOS base. So I'm not interested in that for sure, because I'm not passing an operation that is a function pointer. There's not an equivalent for like std and l that I'm bothering to put in to my text writer. So I guess the only one I haven't done is this one, basic iOS. But that also takes a function pointer. So what in the everything? What am I missing? Just to check my assumptions. STDC out does accept strings. Right. What I really hate about digging into headers in Windows is that all the headers are just like everything is a macro that refers to another macro that refers to another macro. It makes it so hard to just figure out what's going on. Okay, how about this? I'm going to take a type that does accept OStream, or a type that already has the bit shift left operator for OStream. I'm going to confirm that it works with the file writer, and if it does, then I will just do a direct overload for a string. And we'll see where that takes us. Yeah, I'm sure this is something that is covered, you know, week 1 of programmer school, but I missed that day because I missed all the days. Yeah. So what do I have that I can shift out? I think I can do vectors. Do vectors have it with the pretty print library? Let me do a quick vector, std vector of type, I don't know, float, and then it'll be test vector, and I'll set it equal to a bunch of different numbers, 0.0, 1.0, 2.0, and 45,000 dot f, and then that's a vector. Can I shift it out? I can. Okay, so there's no complaint. I don't have a squiggly red underline of death. Let's try that with the writer class now. Writer, shift out. I've got a complaint. Okay. So the operator here works fine with vectors. You know what, I'm thinking it's because the cout is of type OStream, and OStream as the left operand is what is overloaded. So perhaps the reason why I can't shift strings out is because there's no free function operator defined from std string in the string header that specifically makes note of my library. That's probably what it is. I'm guessing. I'm gonna test that assumption by commenting out pretty print. So pretty print is responsible for allowing this to work. Let's go back to pretty print. So pretty print is just a single header, I believe. It's a pretty cool little library that more people should use. But it's basically you just include the header in whatever file you're working in, and then when you go to try and print something like a standard container like a vector, it'll just work. So std vector is not mentioned in here specifically, so one of its parents must be. And it's what? Doesn't it have a parent? I'm sure it's a derived class, but maybe not. Maybe it's all by its lonesome. Interestingly, there's only 3 operator overloads here in the entire thing. The first takes an OStream. They all take OStreams on the left with tcar and tcar traits. And on the right, they take print container helper, template object, custom dilems objects, and type T containers underneath, and it uses the print container helper to define what is being printed. Let's see what that looks like. Print container helper is a struct, takes type T car, type T blah 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 blah, functor to print containers. Use this directly if you want to. I'm using delimiters type T delimiters, OStream type, basic OStream. Oh, that's pretty clever. So it just assumes that the type has STD begin and end, and it iterates from whatever the container type is from beginning to end. And if the class has those members in it, then the templated type would just automatically detect it. But that's pretty cool. Okay, that's pretty clever on the part of whoever made this, because they don't actually have to specify a specific class type when they do this. They just need to specify delims type or constant T type. So T in this case would be substituted with std vector, and as long as there's a version of print container helper where the delims, if I follow this right, tcart, as long as there's a version of T where it meets all the conditions of this function, then it will print. So this doesn't actually help me very much. It just takes any class that might be like a vector and outputs it. So I can't actually use test vector for my test because it's not actually overloading anything. It's it is not itself got an overload function directly. Instead, it is kind of got an umbrella defined through that complicated template. So what I'll need to do go ahead and do an overload for one of my own classes to confirm that I can do it correctly. So the first thing I need to do is I need to find a class. I think I'm going to go into my custom math library, math.h, where I've got my own definitions for vector 2, vector 3, and so on, which I'm going to be dumping anyway in favor of GLM. But I'm going to first just do the operator overload here. So I need to do friend ostream operator, blah, blah, blah. I don't think I've had to friend any operators here. Actually, I don't need to friend anything at all because this is a struct, not a class, so everything is public by default. And I'm not accessing any private members here, so if I just go down here and do the operation, then that's all I need. So I'll do ostream reference operator, where it takes the ostream on the left, and then on the right I do a reference to the object. Oops, I did the wrong thing. And then in this case it'll be const vec3 by reference. 3 by reference. And yeah, let's make this inline. And I need to specify std because I'm not one of those fools who does using namespace std. I just do std ostream. And then I need to return the ostream, but first I need to bit shift out each of the values. So I'll do os, and then I'll do x. Wait, I need to do rhs.x. Then it takes characters, so rhs.y. Actually, I need to do a string literal here because I want a space in there. That's a matter of opinion whether a space belongs in there, but it's my opinion. And then rhs.z. And for that matter, maybe I should do... This is not actually going to be used for anything. I know I'm just doing a test, but I can't help but try and write good code. I'm actually going to put it in parentheses or angle brackets, which is more common for data like this being serialized. Okay, and then I do return OS because the reference needs to be returned in case we're nesting these. All right, let's go back to this guy. I'm going to construct vec3 now. Math. Oh, I'm not in the enterprise namespace yet. Vec3. Test vec equals 1, 2, 3, and I'll just let it automatically convert those into floats, pass those into votes, and let's see what happens if I do test vec. Oh, that's std, right? I need to test it with writer. Doesn't work. So I know for sure that it is still a problem with how I'm implementing the output. Oh man. How is it still 7:38? It seems like I've been looking at the clock for the last hour and it's been saying it's been 7:30. Oh, I got a failure to build somewhere. What did I mess up? Cannot format argument. I'm not even using test vector anymore. SPD log. SPD log is complaining about something, but I'm not even doing anything with SPD log right now. Cannot format argument. Did I leave a EP trace somewhere? I don't think so. I still got a failed. How could that possibly be? Is it simply the fact that I added this operator? I don't know why it would be. Why would adding a bit shift operator cause SPD log to fail to compile? That doesn't seem right. I'm not even invoking SPD log anywhere when I made this last change. Yeah, the build still failed. I'm just quickly going to go through all the cases of the EP prefix in the files I have open. I think I'm going to be getting rid of SPD log at some point because its error messages are not very clear whenever I have a problem, and it doesn't let me do everything I want it to. Like in this case, it's telling me I can't compile because of a type problem. but it is not pointing me to the code that I made the problem with. Gotta be nearly through all of them now, but I'm still not finding a place where I changed the code. And I'm using SPD log. What's going on here? Did I accidentally delete? No, that wasn't it. I mean, that would have been a problem, but apparently that's not what the issue was. I don't get it. I'm sure every use of the... Yeah, I've been through this a couple of times now. So if it's not failing to compile because of a reference, the core.h is in include SPD log format bundled core. So... all right. This is one of those places where I learned something. So first I'm going to narrow down to versions that I might have used recently. Okay, let me go through and do some undos in places. See what I have changed recently. Oh, I know what I did. Yeah, it's really stupid. I was testing with the pretty print header removed. Yeah, at some point in my code I must have used a logging function from SPD log on a container. And because I got rid of pretty print, it's no longer compiling. Oh my god, dude. Alright. Back to where we were. Back to your previously scheduled program of watching me struggle. Come on. Oh man, this has got to be fixed. I know that I'm working on the low-level stuff that applies to like the entire engine. Like I just modified the precompiled header, but that took a long freaking time. Yeah, so the vector prints successfully, but I needed it to print the vec3. If I go back to math.h and I redo or undo the commenting out, I should have an operator there that will work with std cout. And my goal is to make it work with the text file writer as well. I just don't know why. I don't know what I'm missing. There's something that I need to know to make this work that I don't. Either there's an overload that I need that I'm not using, or vec is explicitly being converted somewhere that I need to know about. Yeah, so there's the serialization function that I wrote, and I needed to say 1, 2, 3 when I do writer, but it's not taking it. It'd actually be great if I knew which operands were for the function that's used for here, so I'm going to hit a breakpoint and step into it. Where am I? I'm down here. Operator O stream on the left and vec3 on the right. Oh, okay. All right, I've had my light bulb moment. The problem is that text writer, or text file writer, is not a child of OStream. And for this operator overload to work with it, it has to be a child of OStream. Otherwise, it'll identify the right operand correctly, but it won't identify the left operand correctly. Okay, all right. I guess the question is then, do I want to make it a child of OStream? I guess I do. I still have basic OStream up. It automatically implements the left bit shift operator. I'm gonna have to think about this. Because the reason why the overload isn't working is because of something really simple that I probably would have had somebody who's more knowledgeable point out to me immediately. The fact that this only works when the left-hand side is an OStream and the text file writer is not an OStream. So I guess, do I want to... My two choices here are to make it an OStream, because a lot of classes are designed to be shifted out to an OStream with the OStream overload operator, and like Microsoft even has like a tutorial on it. But the alternative would be that I just don't do that, and I have to have all the classes that shift out either serialize themselves, or they overload an additional operator that takes a text file writer as the left operand. I'll have to think about that. That's a complicated one. Because I really want to be able to just, for free, have the ability to serialize out things like vec3 without having to write an operator overload. But the extra things that I would throw into the file writer might not be worth it. Like I've got all these things that I would never use, like flush. I don't know. I'm gonna take a break and come back to this afterwards after I've had a chance to think. Alrighty, we've had a little bit of a break. So before leaving the stream, had the fundamental revelation that the reason why OStream operators work is because all of the left-hand operands have to be in OStream. And it sounds really, really basic now that I'm saying it out loud, but I think there was a little bit of magic to OStream operation that I just didn't understand. I just kind of assumed it worked by merit, that that's how the operators worked. But in truth, the thing that causes it to work is the fact that the left-hand side of the operand is always an OStream. And when you go to overload the operator for a class like a vector class or like a vec3 class, you are defining an operand on the left-hand side as an OStream. So I'm left with a choice to either make text file reader a child of OStream, and so that it'll automatically be subject to the OStream bitshift left operators that other classes and structures define, or I could not, and I could explicitly create operators that handle things that I care about, things like std stream, vectors, and so on. There's a couple of details that I want to follow up on before I make this decision. The first would be underneath YAML. I want to know whether the YAML library itself makes its emitter nodes children of anything. Emitter. Okay, so here it is. Class emitter does not appear to be extending any child class, which tells me that even though vec3 works with stdc out, if I was to make a YAML node, test node, and try and output node, is that right? No, it has to be a YAML emitter. I'm not good at this. Emitter, and then YAML key. Is that right? Oh, I need to say test node. Oh my gosh. I am for sure losing my mind. There we go. If I wanted to make test_vec a key, it does not work. Whereas if I wanted to make 15 be the key, it does work. And that's because in emitter.h, let me change the scope to the current document. Operator left shift, it has overloads for these basic types. On its own. And it directly implements a const std string on it. So YAML doesn't do it. It literally just is restricted to the types that it creates its own operators for. And then it puts the onus on the developer to make an operator that is compatible with the YAML library if it wants to serialize that way. That's something that's totally within my power to do. Alternatively, let me take a closer look at the basic OStream class and see if perhaps I can make a child of it and make it the text file reader, so that way, or text file writer, so that way if somebody was to go to try and directly serialize a class that's already got an OStream operator, it would just work. car type, traits type, int type, pause type, off type. So I would make it use like regular car, probably. It would just make it a child of the specialization of this class. Int type, pause type, off type. I'm not sure what int type is supposed to be used for, but it's got a constructor, which what does it do under the hood? Construct a OStream object, yeah. And it's got some things in it that I know I don't want. I don't want flush. I could just not use flush. I could just like implement a empty function as flush. But the point of flush is that you call flush to push out whatever's currently in the OStream. And yeah, that doesn't really have any place here, because whenever I go to write to the text file writer, it will automatically just write to the file, so it's automatically fleshing as it goes. Yeah, so I think I'm at the point now where I've decided that it's not worth implementing the other parts of OStream just to make it work with this thing that I really wanted it to. So what I'll do instead, let me go and back into the math file and undo the operator I did. What I'm going to do is I'm just going to do it the way that the YAML emitter class does, and file.h, and just require that any class that wants to emit a non-standard type, so if they want to write an object using the left bit shift operator, that they just have to make an operator that handles the calling of write with the converted string, which for the types that will most commonly be used, that's not a big deal. It's not a big ask. But anything that's not inelegant or just works perfectly out of the box, I dislike. I want everything to be smooth as butter when you work with this tool. So yeah, I guess that's how it's gonna have to be. In practice, folks are not going to be developing a lot of different file formats using the text file writer anyway. They'll use it for save files. They might use it for I don't know, unique content files. So if they needed to make a special kind of asset file to be loaded into the editor, and that's a ways off. I don't know how or if that would work. Then they might write to a text file writer. If they're in that sort of a situation anyways, then they may then they're already probably writing at the level of code that they need to create an operator that would write to the text file writer directly. So yeah, I think that's the end of the topic. Let me go back to the operator list, this guy. I'm going to, do I want OStream on the right? I don't see any reason to keep OStream on the right now that I've done this. Because anything that I can convert to an OStream on the right-hand side, I'm gonna have to figure out a silly way to convert the contents to a string anyway, which is not gonna work in all cases. So instead, I'll just keep going like I am. I'll do inline text file writer reference operator, left shift, and then I'll just finish out with the types I know I need. I'll need std string. Actually, I need it to be a const std string reference. And then call it, I'll just do v to keep in line with the other operators. I kind of prefer that these be, instead of v, be value. Let me change that real quick. Cool. And then I think I just copied some code from the internet that used the letter V instead of value. And then here I can just literally call write value because it directly accepts std string. So I've got std string, I've got all the basic types. Do I need any others? I guess for now I don't. The math library is going to be replaced completely by GLM anyway. At that point, I can write an operator for GLM values, and I would probably do that. I suppose I could do that here. I would be able to do that in file.h, but I probably would want to define it somewhere else, like maybe the graphic system where that stuff is normally stored. But that's something to do in the future. Are there any other container types I might want? I might want pretty print style writing. Can I go into pretty print .hpp? I'm wondering if I have the power to just come into this header and like duplicate the operators and put, instead of basic ostream as the left-hand side operator, I would just provide the text file writer as the left-hand operator. That would be really cool because I could just like get the advantages of pretty print where I could automatically do standard containers. Yeah, let me see if I can do that. First, let's come back to file.h with the string being written. I just want to confirm that I have the power to directly write an std vector out or a std string out. Okay, so now I've got writer saying this is a string and so on. And I can do now, and then test that out. I can do characters, right? Oh, I need to overload characters. Okay. Because presently that operator is using the operator with the integer on the right, so that's going to come out weird. It's going to come out like OA or OD or whatever it is. But let's confirm first that this actually compiles and works, and then we'll be able to follow out. Oh, there's the problem. Oh, I didn't return this. Okay. And then let me do the operator for characters. I think that can convert to a string. No, I guess it can't. So I'll need to do, it seems like a waste, but really? I can't do a car as in the constructor of, that doesn't seem right. Surely std string lets you take a car as the parameter to the constructor. You got car pointers. Oh, I guess not. That's interesting. I guess you can't directly convert a car to a string. What I can do is I can say address of value. That'll get you a car pointer, which is technically a string. It's a pointer to this value. And by the time write returns, by the time this operator returns, I will have finished writing anyway, so I don't care about the fact that the address is going to go away. Yeah, so that's fine. But yeah, let me confirm that this all works. Okay, what have I got? Oh my god, same murky mistake. Let's return this. These build times are really starting to get on my nerves. All I'm doing, all that needs to be recompiled at this point is the file.cpp translation unit, and it seems to be like it's like recompiling the whole thing for God knows what reason. But let's put that on the back burner for now. Cool. This is a string. That's not a string. What is that? What am I looking at? Oh, you know what? Okay, I know what the problem is. Let's go back to file.h. This character overload, the car value. I'm returning the address of the value. I think what's happening here is that it's, oh wait, no, maybe not. I was thinking that the what it was doing is it was converting to a address instead of a string, but that doesn't seem to be it. So IntelliSense is telling me that it is correctly invoking the operator with the right-hand value being a character. And that this is being converted into a basic string with a constant car pointer. I guess let's inspect it. So the value of car is the new line character. The address is this guy, which is actually what we saw. Isn't it? No, it's not. That's something else. Let's dive in. Step over. The string is being constructed wrong. So for some reason I've got, instead of the one character being written as a string, I've got a 4-character string with just utter nonsense. I feel like I must be in a coma and I'm struggling to wake up. So I can't pass that. Let me go ahead and say SD string, just in the off chance that it's a problem with how it's explicit or explicit versus implicit. It should be implicitly converting the car address into a C-style string and then from there into a STD string, but something's wrong. Okay, the string is still wrong, but now the letters are different. What's going wrong? So I know that the value of car is correct when it comes in. Is there a top 10 list for this? There's literally a top 10 ways to convert a car into a string. Okay. Car C equals A. Well, that's interesting. So the constructor that they're using in this case takes a it does the fill constructor. So you got the number 1 saying that the string is 1 character long, and it fills the 1 character with C, which in this case is the name of the. So that's probably what I'll need to do. I thought it took a C string, didn't it? Converting car into C string. Oh, I'm an idiot. Okay. So in this example, number 10 in the top 10 list, they are using const car pointer. They're just making the address of C, which is basically what I'm doing with the parameter character that comes into the operator overload. And what they're doing here is they're constructing the string using the pointer, the C pointer, and then the number 1. And the reason why they're doing that is because it's not null terminated. This is just 1 single character. And in the C string, if you don't have 2 characters, 1 for the letter and 1 for the null termination character, it has an indeterminate length. Yeah, so that's probably the entirety of my problem. So let me go back here. I need to actually explicitly say 1. I can also use the fill constructor, but is there a reason why fill constructor was 1 and not was 1 and the other one wasn't 1? Like, are these in? I don't think they're in any particular order. It's not like number 1's the fastest or something. So let's go back to this guy. There we go. Address of value, and we'll do 1 to say that it's 1 character long. And that should be enough for everybody. Everything to work in harmony. Come on. All right, there we go. And let's open example.txt. This is a string, and that's a new line character. Man, this should have been done way faster. All right. That's enough for now. We've got the ability to write out all these basic values, the ability to write out strings and characters. The only thing left would be classes that we're going to need to define custom overloads for as we go. Though I do want to take another look at that pretty print header, because with this header being distributed everywhere, I suspect that I can just copy all of these operators, replace basic OStream with the text file writer, and then all these helper templates would just have the power to automatically handle printing those containers out. If that's the case, then I can kind of piggyback on PrettyPrint's amazing container serialization powers and allow text file writer to just print std vector, print std array, print initialization list, or whatever, which would be great. That would make things a lot simpler for a lot of cases. So let me do that. I'm going to copy each of these operators out. And these have to be in, they can be member functions. We'll go back to the class. Leave the template for the second. Is container T. So T is going to be the type of the right-hand operand. Operator, and I'm going to replace operator basic stream with text. Actually, I don't need to replace it with anything because this is a member operator, so I just need the right-hand side. But I do need to replace the basic OStream reference with a text file writer reference. Wait, what? Enable if. Yes, so enable if T is a container. So this is only enabled. This template is only enabled if type T is a container. I don't need tcar or tcar traits anymore because those were only used for the type of OStream. No, they weren't. They were also used for the PrettyPrint container helper. And I'm not in std namespace anymore, so I have to do std enable if. Okay, and I've got no complaints here. Does that really work? tcar and tcar traits have to be left for the sake of the print container helper. I don't know why I would need them still, because I don't need an OStream. Oh, but it uses an OStream here. Oh, it's using a compatible OStream. So it constructs an OStream like everybody. Well, it constructs a functor that takes OStream. I'm getting confused in my head. This probably won't work now that I'm taking a closer look at it, but I'm going to perilously plunge ahead anyway. I've got the bottom one. I'll do the top two now. I would be mighty pleased if it was just this simple, if I was able to just stream out all these SDL containers immediately. Alright. I do need these guys for the moment. I need to return a text file writer reference. And then operator, that needs to be print container helper on top of that. I think print container helpers in namespace detail, which in turn is in namespace pretty print. So pretty print detail I need to specify. Right? Is that not what it said? Oh, pretty underscore print. I'm not sure what this means. Const. I'm not allowed to use Can't I access pretty print from here? Yeah, I can. And then, come on, IntelliSense. I can use detail. Yeah. And then fill me in. I don't have access to print container helper here. I mean, detail is a namespace, not a class, so it should be, everything should be public for my purposes, right? Namespace detail. It's not in namespace detail. Oh my gosh, I just misread it. So it's only in namespace pretty print. Namespace detail ends right here. Okay, that makes sense. Okay. Too many parameters for this operator function. Oh, that's because I don't need the left operator. Boop. We're down to one operator. And that's that. Okay, now we just gotta take care of this one. Same thing as above. I need to do text file writer as the return type. The left operator needs to go, or the left operand needs to go. And then custom to limbs, I'm going to go out on a limb and say it's in the pretty print namespace. It is. And that's that. So these are the three functions that are the three operators that were overloaded that take advantage of the print container helpers. I'm a little nervous about this tcar and tcar traits, which are needed for constructing a functor that uses an OStream, and I'm nervous about that because we don't actually have an OStream as the recipient here. But I guess that's the way the cookie crumbles. Let's see how this goes. Does this compile? Actually, now that I say that, I know that it will compile because I'm not using it anywhere, and these are templated functions. The question is whether it allows me to output things like vectors. Yep, I know. So let's do example vector equals, I don't know, 5, 4, 3, 2, 1. So now I've got a vector. Let's do no, all that work. I thought that I might be able to just not have to think about it and then have it accept containers. Let me open up the pretty print documentation, if there is one. The reason why I'm looking into this is because I'm wondering whether it allows you to pretty print to things that are not OStreams. Yeah, so I guess the library wasn't designed to allow this sort of a thing, where I could like overload an operator and take advantage of the templates. But I feel like I'm so close. Let me dive further into how pretty prints sub requirements work. So here's the operator. Let's go to these other template types. tcar. I'm not using the OStreams anymore, but the print container helper. Which is actually not used for all of these. It's only used for the first and the third. Print container helper requires those extra template parameters. Let's take a look at how that works. So in this case, we've got an OStream on the left, we've got a container on the right. We're pretty printing using pretty print container helper that shifts out to the left. What does it do? It got delimiters. It provides a function called printBody inside of a struct called printer. And this is the actual functor. It looks like stream shifted in delimiters type values.prefix. I don't know what that's about. This appears to depend on O streams. So when it goes to print, it actually uses the stream operator to do that printing. And because the left-hand operand that I'm trying to override right now is not of type O stream, this will never work. I would actually have to go in and rewrite the code so that way, instead of using the bit shift operator to the left to write to the output, I would use something else, or re-explicitly write that code to handle the text file writer. So I guess it's not that simple. All right, that's too bad. It would have been nice, but I guess that's okay. For any situation where you might write a class to the temp file writer, I think it'd probably be in my best interest to take care of all the fundamental data containers. So not necessarily all STL containers, but things like matrices, vectors, and things that you would want to serialize as part of the world state or as part of the game state. But we'll have to come up with those as we go. But for now, we've got a writer that works pretty well. It creates the file in the temp folder and moves it over atomically to prevent problems with corrupt files occurring, like power outages and other processes interfering and things like that. So it's a safe way to write files. It does this in a way that is portable, so that it's pulling the API for Windows or Mac OS. Still have to implement Mac OS, but it's pulling the APIs to get those locations, and it's getting a unique file name from the operating system. Everything seems to be working pretty great. So I think I'm okay leaving it as is. Now that I have a simple way to write to files. I've got the ability to dump to files using file save text file. And I've got the ability to stream to files using the bit shift left operator on all the fundamental types. And then more complex types I'll implement as we go. As far as what the next steps are, I've got scene serialization is working great, including the ability to save any new kinds of entity systems that people might develop. So I can technically start writing a renderer now and be able to construct scenes including those renderer components. So I could do a sprite system and then construct scenes full of sprites and display those. Yeah, there's actually a lot of directions we can go with this. I guess for the next steps would be to clean up the API and the documentation for what we have developed so far for writing files in the file system. Get that implementation working on macOS. So I've got to fire up my laptop and actually do the definitions that are missing on macOS. And then from there, I can either go in the direction of writing my first renderer for this engine. So if you wanted to use an out-of-the-box sprite renderer, we could do that. I could go in the direction of starting to create the editor for creating a GUI for constructing scenes visually. I could also go back to a few areas that were pending the creation of the file writing system, like the ability to save INI files. I could write an INI file writer, and that actually has some larger application implications than save data, because using INI files as configuration files works for a whole bunch of basic things you don't think about, like whether the window opens in windowed mode or full screen mode by default, the position on the screen or which screen it should display on by default, things that you would ordinarily save to file in between running the application before and after. But I just didn't implement before because I didn't have a proper file save system. Yeah, I'll have to decide what I want to do on the next stream, but it seems like this is pretty much a wrap. I just got to do some implementations for the API that I've got, and that should be a breeze on macOS. All right, have a great night. Bye-bye.